Am I awake yet? No. Any of you? I guess not either. Okay. Is anybody here from outside the country? Not speaking. 1, 2. Wow. They're really coming from a long way away. Did you have any trouble at the airport, sir? You with the beard. No, I said, did you have any trouble at the airport? No, too. Yeah? Yeah, you check your shoes. Yeah, I seem to always get the wrong airlines. I don't know why they screw with me all the time on these flights. But anyway, thanks for all being awake this morning. Our next speaker here has come all the way from New York City. His company is called Immunity. I've been asking a lot about that lately. And his name is David Aitel. And his thing has to do with strings, and I'm going to let David tell you all about that. So please welcome Dave Aitel.
So I can't actually display both on my laptop and on the screens, so I'm going to be flipping papers in case you're curious what that is. But this is Spike, which is actually named after the Buffy character, in case you were curious. But I'm Dave, and my company, which does sort of consulting services, is called Immunity. And after the talk, I have some CDs here and some cards and stuff, so the first 20 people get CDs with the new version. So we're going to do like 2 little quick slides, and then we're going to move along right to the demo so that you get a better feel for what's going on. Oh, clicked on it. I've got VMware running, so I have about 2K of memory left. Okay, so the agenda basically is just going to be a quick demo. We're going to go over kind of, after the demo, the theory and kind of the goals and why Spike was created. And we're going to look at how to use Spike for you guys to sort of find new vulnerabilities. And of course, if you have a question, there'll be kind of interludes, and at the end we'll do a big question section. And this is an actual quote from Gobbles, who apparently saw the light after using it for a little while. Okay, so now we're going to switch over to a demo, which is going to be a little bit harder than I expected because we can only display either on my screen or that screen. So I'm going to kind of flip back and forth. And hopefully VMware will participate in this. Okay, so we're going to be demoing 2 new vulnerabilities, or there's 2 new ones here and sort of a few sub-vulnerabilities. One is in Microsoft SQL Server. The other one is in Microsoft Exchange 2000. And it's just a Windows 2000 SP2 box. So the first thing I'm going to show you is one of the tools that comes with it, which will appear now. So DCE dump, which is a tool that I wrote a long time ago, does raw MSRPC to the endpoint mapper, which is port 135, and gets a list of the programs running and what ports they're running on, much like RPC dump for Solaris would. That looks like this. So you get a long, long list of just what is running, and you'll notice if you probably look at the screen, not that I can, that there's probably some Exchange programs running on this particular Windows 2000 VMware box. I'm going to switch over. And I'm going to try to find the MTA, which is the thing we will be crashing. It is the mail transfer agent, in case you're not familiar with that. And the basic idea is just to look for the port, which is in this case 1195. Boop. You can just kind of see where it says TCP port 1195 is running this MTA service identified by an extremely long string. So I'm going to take that port, which is, a lot of people leave Exchange 2000 listening, and they leave all their ports open on their Exchange server so you can do the nice features of running Outlook and integrating your calendar and all that stuff, which all works over MSRPC. And usually they do this to the internet unauthenticated. We all know that's a bad idea, but people still do it. So 1195 is the port, and I've got a little script here, which I just call kill MTA. And you can see this script real quick. Okay, this script is going to run part of Spike called MSRPC fuzz, which will go to the particular host port, and then you're going to see two extremely long strings. And one of those long strings is always the same for every time you ever use this program, and I need to make it a default, but I haven't yet. And that string says that I want to use the sort of specific Microsoft RPC encoding scheme. It's really just DCE RPC, but there's only one that they ever use, and that's it. And it just specifies that it's going to be Intel order, integers, and strings are going to be a certain way. So like with Sun RPC, you only get XDR. That's the sort of marshalling functionality that you get. And with DCE RPC, you can specify how you want integer to be flown over the net. And they always use the same one, so it's not a very useful feature. But in case they ever change it, Spike will let you update that string, because you actually need to specify that when you request a connection to a service. So basically, I'm going to connect to port 1195. I'm going to say, can I please talk to the MTA service? And then from that point, MSRPC fuzz is going to send a bunch of random but valid sort of MSRPC requests to the MTA service, which eventually, longer on a VMware box, is going to cause an access violation, which will shut down the MTA, and no one will be able to send any mail. And I don't know whether or not this is actually exploitable, because I haven't looked at it. I got busy doing other things. But I'm sure some of you will take the opportunity, download Spike, install Exchange, which takes a couple days actually, and then crash it and see what you get. And inside the Spike directory, you'll see a little audit directory, and then an Exchange 2000 directory, and there's some notes in there about how to do this and another couple ones. So let's actually run it. Uh-oh. Which screen do you want to be on? All right, so we're just going to run it with the port, because the port got put into the port operation for the other script. And my machine will quickly run out of memory as VMware swaps around. And it goes pretty slow on this particular setup just because VMware is taking up all the memory. But usually it's fairly fast. And eventually it will start saying connection refused or couldn't TCP connect to the socket. Is it saying that or not? No. Okay, we'll let it have its fun for a little while. Though it does take some time. So that's the first vulnerability. There's another vulnerability in Spike in the current sort of audits Exchange directory that does a similar thing. Again, another access violation on a different function, because then in MSRPC, just like Sun RPC, you have sort of your program number, then a function number. So when you call function, I think this is 2, it causes this access violation. And when you call function 8, there's another access violation. That's quite a good time. But if you call function number 0 with this program, it'll actually allocate 256 megs of RAM and cause blue screens. So if you're in the mood for something a little bit more permanent than just crashing the MTA, you can blue screen your Windows 2000 box remotely this way. If you happen to like doing that. So, is it saying couldn't connect yet? Okay. Sorry about that, couldn't see it. So when it says couldn't connect, that just means this port has gone down and it's no longer running. So we don't have an MTA anymore. So that's one vulnerability. So enjoy that. And now I'm going to show you another vulnerability which is on SQL Server. An SQL Server has basically two introductory packets. You say, hello, are you running MS SQL Server version whatever? And then it sends back, yes, I am. And then you send back, well, here's my username and password. And so during the hello request, I'm going to tell you the vulnerability first. During the hello request, the first thing they do is stir copy the version of MSQL Server that you asked for into a 512-byte buffer. So it's kind of, as someone mentioned last night, it's like, you got me with hello. It's just a, it's a very quick, and they do it again with the password and username. So if they fix this one, you have 2 more shots. This bug only took a few minutes to find, but I thought it was quite interesting, so I thought we'd demo it. And this is over TCP port 1433. It's not the same one David Litchfield will be demonstrating this afternoon. And as far as I know, it works on Service Pack 0, 1, 2, and everything. It works on everything. It works on the MSD or whatever that is. And it is system. I noticed in the Microsoft advisory for the previous one, they said it wasn't system because the default is domain user. But the reality is you're running with a little screwed up token, and you can't exec command.exe. You can do everything else. You can upload a command.exe and exec that instead, and that'll work okay. So if you end up exploiting this tonight, that's how you do it. And it's not too hard to exploit. So let's give a quick demo of that. Have it here. Oh, actually, first I want to show you what a spike script looks like. And it looks like, for some reason, the spike script has disappeared. Give me a second here. Okay, this is the spike script that I created when I was first looking at the port. I just basically captured some quick traffic with Ethereal, and then I copied it into this little file, and I changed one thing instead of being binary to be this string variable, which we'll get into later. So I mean, don't spend too much time trying to figure it out now. I mean, this is a very basic spike script. It gets interpreted. It's a little C interpreted. Anyway, we'll go into it. But anyway, this is what it's going to start sending out. And there's another program that takes these things and sends them out to ports and sort of increments and stuff. So that program is what we're going to be running now. Okay. So I just catted out the script so you could see that I had nothing, in my sleeves. And I'm going to then hit enter, and we will see the sort of results of what happens to Microsoft SQL Server. It should go up to about 30 and then stop because what happened is the server started freaking out. So 30 is the number where Spike sent actually a very long string that was smaller than the maximum that it could handle. And SQL Server is now crying and moaning in pain. And I just want to quickly show you if VMware is happy with me, which it almost is, what the event log looks like for these attacks. Am I loud enough for you guys in the back to hear? Is it good? Okay. So in a few more seconds after we swap some, what are we doing? All right. So this is the SQL Server access violation, and this is actually exploitable, or I should say easily exploitable. Everything is exploitable. And if we go down far enough, we will either pass through or on the Exchange server vulnerability. So either we hit it or not, I can't really tell. But so that's Exchange. There's 3 actual vulnerabilities included in the release of Spike, which is out today. And this one SQL Server vulnerability, although if you really want another one for some reason, you can go look at the next packet. So hopefully you all enjoyed that. I'm going to give you a very brief demo of Spike Proxy, which is a product that I wrote so that Sanctum's app scan would stop annoying me. And then we're going to move on to the kind of theory things. So did everyone have fun with the remote roots? All right. Hopefully that woke you up. VMware is not going away. Xkill. Please go away, VMware. There we go. Okay. I'm going to set up Spike Proxy real quick. Normally you'd get to see this. The only reason I couldn't set up it before was that I don't have enough memory to run both a web browser and VMware and OpenOffice. So this is actually included with Spike as well. It's a pure Python SSL man-in-the-middle proxy. So it basically does what web proxy does. It does what AppScan does. It does what the other sort of web assessment tools do. Can't remember all of them. There's so many. But it's completely open source, completely written in Python, so it's very easy to modify. The crawling isn't done yet, although the crawling is actually quite easy, and I don't think it's quite as useful as companies like to make you think. But the best part about it is you can sort of organize, it saves off every page you visit while you're going through this, sort of in a permanent store, because Python has that pickle function, which is quite cool. And then you can go through and you can sort of browse it later, or you can just tell it to just run through the entire site or everything below a certain directory and look for ODBC errors, look for overflows, whatever you happen to be looking for. And if there's it saves the cookies, and it won't save pages that are the same. And so if you get a chance, I encourage you to download and try it out and let me know what you think. It has a little request cache, which right now is going to be empty because we haven't made any requests. But it's quite simple to use, really, and hopefully it will get rid of all those ODBC errors that are making everyone so much money, annoyingly enough. So that is Spike Proxy. I'd do a more thorough demo if I had both my screen and the other thing, but don't have that. You do need Python 2.2, it turns out. The most common message I get back is it won't run, and the reason for that is you don't have Python 2.2. And it also requires this PyOpenSSL module, which you can get right off my webpage. All right, so we're going to just briefly, I'm going to give you now the URL. You can download Spike if you're on the thing. It's just www.immunitysec.com/spike in all capital letters 2.5.tar.gz. So for those of you with a laptop connection, you can download it now from my website. Although honestly, I host Gobbles' site, so that site's probably been hacked because it's hosted. So you should also download the .sig file and make sure that you check the signature. Yes. But it's GPG, so hopefully no one has my key. I mean, no, hopefully you have that already. Okay, so we're going to move back into a bunch of slides now and kind of discuss the theory. Now that we've hopefully woken you all up. That's good to get hecklers. Shows you care. All right. So that was the cool demo. Okay, so now we're going to talk about, why, what, how, when, that sort of thing. So the theory about Spike is that I was doing sort of some engagement work for another company, and I ran into a protocol called Rendezvous, which is written by a company called Tibco, which they'd actually tunneled over HTTPS and encapsulated in sort of posts that were going back and forth, and there was this whole layer stuff. And I didn't have anything ready and sort of willing to quickly rip off the HTTP stuff so that I could quickly sort of disassemble the protocol underneath and manipulate the raw. It was a binary protocol, and so it's really kind of very difficult to sort of manipulate with the tools that were available. And so I started Spike just to handle that. And I've done a lot of other sort of protocol, reverse engineering, a little looking at, flip the field here, make the strings bigger. I mean, in some case, you get a very simple, the Spike script you saw for SQL Server is like the simplest Spike script ever. So, I mean, that doesn't really demonstrate the potential, but it does demonstrate a nice remote root. So that's why it was included. I do already sort of support a lot of primitives and stuff, and we'll go into what Spike can do now. And Fez is Frank Swiderski, and he's just always, everyone is always surprised at how effective it is to make small strings bigger. I mean, reality is a lot of the bugs that are exploitable are single function bugs. The problem itself of fuzzing is exponential, but because so many bugs are so simple, you can still get into most machines with a fuzzer. So the goal of Spike, then was, I mean, this is the security space. We are looking to find new vulnerabilities. And to do that, it's useful to be able to quickly reproduce arbitrarily complex protocols. And protocols are almost all exactly the same, luckily for us. So this becomes possible. And also, once you have a Spike that does something, it can do that very quickly against lots of other protocols and find similar bugs. You try to abstract away as far as possible the bug without taking up forever. And that way when you Spike a different program, maybe you find a similar bug that's not quite the same, or maybe it combines a bunch of bugs and you get lucky. And so the goal is to get lucky. So let's look at kind of what tools. Spike is written in C. It uses all sorts of weird C-isms, but it's semi-portable. It doesn't really work on BSD yet because I do some strange things with DLOpen and DLSim. But also I don't have a BSD box at home, so that's kind of why it hasn't been ported that way. But the basic sort of uniqueness to Spike is a data structure that I sort of threw in there, which is called a spike, confusingly enough. Spike is a way to sort of encapsulate your knowledge of the way the protocols are blocked out. Most sort of data transfer protocols, they have length, block, length, block, length, block, length, block. And the lengths and the blocks can be sort of interlaced, they can be nested, they can be arranged in many different orders. Spike makes it possible to quickly represent this sort of length information in a way that you can then easily manipulate. And it's just a very simple, you start a block, you end a block, and in the middle, whatever you decide to put into the block is counted up, and then anything that wants to know that information can. So that's one of the sort of sections of Spike, is just dealing with figuring out the length information properly. The other section of Spike kind of encapsulating marshalling routines. So making sure that when you say, I want a string that looks like Sun RPC's XDR string, you have that available. Or in the case of a lot of the Intel protocols, a lot of the Microsoft protocols, you have a bunch of things where they do kind of a flipped half word and then a string, and they won't round it out to 4 bytes. Or all these things I try to keep sort of in Spike's toolkit. So whenever you say, I just want to pretend to be this string, you can do that. And then if you want to say, I want this string but a lot longer, it'll know to update the length field at the front and do the right thing with the rounding. So that sort of thing is all. There's a bunch of routines in Spike that handle that. And of course, there's a bunch of routines in Spike that handle sort of encapsulating your knowledge of what functions, what kind of strings make programs crash. You know, long strings of the following lengths, because in certain cases you need the right length to crash it. It has to be on a mod 8 boundary. It has to contain a certain character, et cetera, et cetera. So I have just a list of these, but it's not an exhaustive list because that would take forever. So the idea is to try to distill down the sorts of strings that make programs crash or cause them to evidence bad behavior and therefore find bugs. I have just a quick example of just what sorts of normal things you see in a Spike program. And that would be a S string, you know, of a host that says put the host into the thing, and then after that I'm going to want you to say localhost when I'm not fuzzing this variable, or otherwise put something, you know, like a long string of A's in this place. So that's kind of one of the 3 sections to Spike. So a data structure, I mean, in this case it's just a very simple, you can push data into a Spike. It's stored as simple octets, so it's just a bunch of bytes. And one of the reasons that I don't have it ported to SIGWin is because Windows complains if you try to malloc or allocate, you know, 1 million bytes on the stack, whereas Linux seems to think that's perfectly okay. So that's one of the things. And you can just see, in this case, I'm just got a little code snippet. Blocks have a key that identifies them. So you say, this is the block that identifies the start of a post and the end of a post. And whatever's in between there, we're going to call post, and that's the length of post, whatever was the length of stuff in between. So whether that's binary data or just, you know, I mean, HTML or HTTP is very simple. It's a very simple, you know, ASCII sort of protocol. So Spike treats it as a subset of the binary protocols that it actually can handle. In this case, you see me just saying, we're going to start a post, we're going to end a post, and I'm going to take 5 bytes before that and allocate that and say, fill these with zeros now, but when the block ends, come back and tell me how long that was, and I'll print it in those blocks as a sort of ASCII number. So at the end of this, when you see S block end, it's going to go back into the Spike and fill it out with, you know, 0008. Or 0008 or whatever. Yeah. So that's what's going to happen with the little code fragment. So length fields, because they come in so many different variations, you can say, I want to put a length field in this part of the block that is this size, that is this, you know, this kind of data. So it can be all sorts of things from, you know, Intel aligned, you know, network order aligned. It can be half a word, it can be an ASCII string. Any way you can represent a number, people have tried to do that over the wire. So Spike will just take that and just convert it for you. And obviously, more than one field can have the same number in it. You can have interlaced or nested lengths, and it handles all that properly. So if you think of like a very complex RPC protocol, I mean you can think of a very simple one if you're comfortable with it, like Sun RPC, where they have, you know, the packet comes out and it says this is the length of the packet. And then you have the rest of the packet. And inside that packet, you have the length of strings, you have the length of arrays, you have the length of this and that length of that. And so when you want to make one of those bigger, you have to adjust everything that needs to worry about that. And so Spike lets you adjust one, and the rest adjust themselves. So that's the basic theory of the data structure. Okay. So moving ahead. Just the basic calls to get you comfortable with the API. You basically push stuff onto it if you want to talk raw, although you never really talk raw unless you've got a big buffer of bytes that you have that you created somehow, like a big thing that's got encrypted. You can put strings on there, and these are just normal ASCII strings. It doesn't throw the trailing null on there. You can throw a variable on there, and the variable stuff comes in later when the fuzzing happens. It knows that anything that has a variable, it will eventually replace with a bunch of other things. And you have this S-binary function, which is extremely useful. You saw that in the MSSQL spike. And that will actually just parse whatever you've got in between and handles a bunch of stuff, so it makes life easier for you. And that just converts it to binary as if it was hexadecimal numbers that you copied out of Ethereal, which is usually what it is. So that's that. Okay, so there's a few other things you have to do, obviously, with Spike. It's basically C++ written in C, and there's really only one spike at a time that the Spike routines know how to handle. Originally, I thought Spike was going to be much more portable than it is, which is why I did it that way. But basically, you can tell the Spike engine what the current Spike is going to be and flip between them and save them off if you really have to. You really only have to do that for extremely complex RPC protocols like MSRPC. But usually, you only have one Spike, and you never have to worry about it except at the beginning of the program. Another thing is Spike clear. Spikes maintain some state, like what server they're connected to, the sockets, and that sort of thing. Spike clear doesn't clear any of that. It just takes all the data out of the spike and scrubs that, so that when you want to just reuse the same spike over and over, you can just clear it and then fill it back up and send it back down the wire. So mallocs and frees and stuff, you malloc memory, you free the memory. So you don't want a memory leak in a tight fuzzing loop. Basic, just things, utility functions to make your life easier. Spike knows how to connect to network protocols. That's what it does. UDP, TCP, you send stuff, you close stuff. All the basics are there. Okay, so the fuzzing framework is it's not primitive, but it's not complex, so it's easy to understand and add to. Basically, it has a big list of strings where it will take the string that you tell it to replace. It can have like 5 or 6 or however many S-string variables in a program. And basically what you do is you just go through any protocol you have, and wherever you would normally put an S-string, you put an S-string variable. And then as you throw it through the loop, it connects to the server, or the server connects to it, or whatever. And it increments as it goes through, and it says, well, now I'm doing this particular field, and then I'm going to replace it with a long string, and then the next time it goes through, it replaces it with a longer string, or replaces it with ... or something, right? And then on the other hand, you sit and you look for bugs, or usually attach to the program and try to see what it's doing. Maybe attach with strace and see if it's accessing anything that you think would be interesting. So basically, I've tried to find a way to encapsulate knowledge about what sorts of strings cause bugs. The HTR bug, for example, was found by Spike, the original HTR bug. I know there's been a lot, but there was a heap overflow that I found that sort of this year, and it's an off by one when they do it's sort of an off by one. They throw that last null in there. It overwrites the last byte of the sort of heap structure, and that's how you get control. On Windows, it's quite easy to get control when you just do the last byte overflow. And the only way you can find that is actually by trying after you overflow it, and then you have to try each sort of out of 8 alignments. And that way you eventually get the one that does overflow the byte and it crashes. So I've tried to encapsulate that kind of knowledge in Spike to get it doing enough but not too much and that sort of thing. Another case is use certain, you can either choose to do all the various characters for the overflows, or you can choose to do just certain ones that cause overflows. Like in some cases, the server will send you will send it a request, and then it will sort of parse your request and replace, say, a quote with a / quote, which will double the size of the string and then send it back to you. And sometimes that's when it will actually overflow. So I have a bunch of characters in there that I know get replaced with things in certain protocols. And it's quite easy to add stuff to this. So you have loops that you can hit Control-C and you can resume and stuff like that, which is useful for some programs that stop accepting things and then restart them later. So those are the major advantages when you're looking at you're like, well, I could just write a Perl script to parse this protocol and send the data out, or I could use something else. But the reality is actually implementing a binary protocol with Perl or anything else can be quite a pain if you don't know the actual protocol. And Spike is designed to give you, with your imperfect knowledge of the protocol, a way to leverage that and kind of fuzz the parts you do know and hopefully find something interesting out of that. It can handle binary data nice and cleanly. It can handle large sort of packet sizes. And it can integrate nicely with anything you've got on the side that is also C, or even another program if you do it right. It's GPL, and so one of the things that I did was use the Samba's libntlm to be able to authenticate against IIS servers. And there's very few programs that can actually do a brute force on the IIS NTLM auth. This is one of them. So what is the process of actually using Spike on an unknown binary protocol? Basically, like I said, you take Ethereal, or you take whatever knowledge you have of the protocol, and you try to push that into a Spike script. And then later on, you'll push that into an actual C program if you want to. Sometimes you don't have to. But in this case, you can say, well, this looks like the programmer is doing XDR style strings. So I can just replace it with an XDR string, and then later on, if I want to manipulate that value, I can manipulate that value cleanly, and the protocol should still work. So you go through and you kind of just fix the basic stuff up, and you try to send the protocol, and you see if it works. And if it works, you say, great, and then you try to understand a little bit more about it, and you replace all the length fields that you can find, or maybe there's an index that's counting up or something, and after that index gets counted up, of course, it has to be flipped into Intel byte order or whatever. So you try to find all these fields that you can know about, and you quickly mark them up in the Spike script. So you've got a bunch of S binary there, which is the stuff you don't understand. And you have a bunch of kind of the higher level stuff, which is the stuff that you do understand. So at each stage, you try to make sure the protocol still works, because I mean, it's important to get past the front door. And that's actually somewhat difficult with MSRPC, because the protocol is somewhat complex. But with other protocols, it's usually quite easy. They drop the connection or whatever. So after you do that, you just quickly throw it into a little while loop to do the fuzzing. And there's a ton of examples about how to do this in there. And it goes through, and it'll send the long strings. And then from there, you can kind of try to manipulate the set of strings that it will send to tune what you think will crash it. If you start seeing error messages, you can throw things onto the front, throw things onto the end, whatever you need to do. So, and then you write up the exploits, as we've seen with SQL Server, which can take a couple days, depending on how hard it is to find. So let's talk just briefly about, when I say I have a scripting language built into Spike, what do I really mean? I wanted to make it easy to take the power of C and reduce it to something you could quickly modify. So there's a tiny little thing in there called DLRPC, which if you went to Max's talk about syscall redirection, it's similar to the Windows way of doing that. So basically, it'll parse the file. It'll say, I can marshal and unmarshal a few basic types like strings, numbers, that sort of thing. And it will pretend like it was C, and it will execute it as if it was C. So that Spike script you saw for the MS SQL thing, you can take that and plug it right into the framework, and you'll have the power of C. But if you want, you can leave it as a Spike script while you're doing your sort of R&D development work before you really want to narrow in on something. So I mean, basic things that are completely valid Spike script is you can print things out. You can do all the sclear, all that stuff. You don't get loops. You don't get any of that. But you do get the ability to call any arbitrary C function. So typically what you do is you're going to build one of those quick generic frameworks that I've got. You're going to then write a little Spike script to try to replicate the protocol. You're going to maybe change a few things to fuzz it real quickly. Most things don't fall as quickly as SQL Server. And then you're going to put it in an actual C program for the real hardcore work. So that's how the framework works, and that's how kind of the global roadmap for the API. And the tools and examples in there I think are worth talking about as well, because you're going to want to know, I want to replicate this protocol. What do I look at to find how to do this with Spike? And the way you usually do that is, we've got a bunch of these that are very web focused. We all get a lot of sort of web application work. So there's a lot in there that handle HTTP quite well or do various things with HTTP, break the protocol in certain specific ways. There's a lot of them that do MSRPC, and there's a lot of them that do other sort of miscellaneous things that you're going to see, UDP protocols that I think are common. Specifically things that do like non-web apps. You're going to see these, Citrix Fuzz, Quake, or Half-Life. These things, like Quake and Half-Life, have very, very similar protocols. And it's important to be able to take anything that's going to look just like that, and there's a lot of things that have real-time UDP sort of similar protocols, and quickly analyze them. And so there's an example in there for that. And it also does the reverse. It'll pretend to be a Quake server. Because if you think about it, one of the really interesting attacks is advertising yourself as a Quake server, and then owning the 100,000 people that come to connect to you. So it'll pretend to do that as well. One of the common things you'll find using spikes is that programs run out of licenses if they have a license restriction. So actually, if you use I have a bunch of Exchange Outlook web access scripts in there in the Spike directory that you'll get when you download it. And if you use them correctly, they actually will cause IIS to run out of licenses for Exchange. And it will no one will be able to connect to Exchange anymore because it will think it's out of licenses, even though you've just connected to it from one host and broke the connection, right? So, I mean, there's a lot of these license, draining attacks, which are extremely dull. So I don't want to see any of those on BugTrack. Citrix is another one of the example of this. I wanted to get into that protocol before the company goes out of business. And just looking at the basic of the thing, you can do a lot of these I've run out of licenses, I can't let anyone else connect attacks, and it's really dull as well. So if you report that on your reports to your customers, they should laugh at you. And MSRPC fuzz is like an example. That's kind of one of the prime reasons I wrote something like spikes, to be able to handle things like MSRPC, which no one looks at, right? Like only Todd Sabin has really produced anything similar to this. And obviously there's a huge potential for that. I mean, every couple days, Sun gets owned through a Sun RPC attack. And you don't see that with MSRPC because no one can figure it out. And another exciting thing of using it is that you can actually, the way RPC protocols work usually is they'll have this little file, like an IDL file, that says what the variables are. And if you know what the variables are, you can plug them right into Spike, because Spike will handle that kind of thing. Not the actual IDL file. You have to do a little bit of work. But if you don't know what the variables are, you can keep using Spike at it. It will throw a random type at it until it eventually succeeds in creating a call, at which point you now know what the variables were, or at least what the types were. You don't really know exactly what they were, but you have kind of a linear picture of what they were. So it can help you do reverse engineering on the RPC protocol itself as well. So just a quick start on how to use MSRPC fuzz. You saw it briefly. Use DCE dump, which I now include with Spike because it's really only useful with Spike. And I have to say, one of the things about open source is that I sent out DCE dump like a year ago. And a month later, a Norwegian guy, whose name I forget, sent it back to me and said, I totally fixed it. It actually works now. And also, it's 150 lines less. So hopefully you'll enjoy this. And I was like, yeah, excellent. Because I don't have time necessarily to make it all work. But that's good. So basically, you have really two variables. There's really three variables. There's what program number, what port it's on, what TCP port it's on, what version of sort of function that is. Those are the only three things you really manipulate when you're using MSRPC fuzz. And I think a sort of exercise for the readers would be to go fuzz XP with this, because I guarantee you will find something. Okay? I've done it. I found something. So if you don't find it, something's wrong. So that will be a fun exercise for the readers. But otherwise, it's just a good example of how to do complex things with Spike as source, in case you're in the mood for that. Spike programs for web apps. this is something that Spike does a lot of just because there was a lot of work for it. It's not something Spike was explicitly designed to do, unlike other programs that do kind of protocol fuzzing. It doesn't natively just do web. I had to throw a lot of stuff into it to do web because it's really very generic. But it does web well now. One of the things it can do is it can do NTLM auth. You can authenticate, say, to a front page server and fuzz everything with the permissions that you have. You can authenticate to any sort of IIS protected app that does NTLM and then look for ODBC errors on that page automatically, right? So, I mean, that's kind of the benefit. You don't have to tell your customer, hey, can you switch that to basic auth because I don't have any way of automatically analyzing, your 100 pages with anything that I've got because you're using NTLM. So that's a good thing, and I think that alone would show you kind of why I wrote this thing. MakeWebFuzz.pl. When I actually first did this slide pack, I hadn't learned Python. Spike Proxy is my second Python program. So I used this really crappy Perl script, because I don't know Perl either, to take HTTP requests and transmute them into Spike scripts. And it'll do that, and it will do that okay, but it's kind of outdated. And there's a little Python script in there that does it much better now, which actually I was going to demo, but I forgot. The other thing is webfuzz.c. That shows how to do some basic C fuzzing. You want to look at a page. You want to look at it closely. You want to start incrementing stuff. There's basically a C program in there that demonstrates how to look at a sort of post or a get with some detail. And the other thing is the closed source web server fuzzer. I wrote that because I wanted a quick one on IIS, and it found the HTR bug and the other overflow. So it's quite good, and it's kind of generic, so it's found stuff on all sorts of things. There's Java application servers out there that have sort of overflows in them in the core. There's all sorts of good stuff. It's just very generic, but it's a good example if you want to look at something kind of in a generic way. So quick, like QA exam for every web server company that can run GPL software would be to run closed source web server fuzzer on your web server and make sure it doesn't die right away. Very simple and easy. The generic web server fuzz is the sort of new generation. You've got something you want to look at closely. You put it in a Spike script and then throw it through generic web server fuzz, and it will do the right thing, and it will do it quickly. It's kind of optimized for speed, actually, because you're going to throw like 50,000 requests on a web server. You want it to be done today. And so I don't wait for the request to finish in all cases. It's not multi-threaded, but it just is quick. And to give the IIS guys some good news, they're much faster at responding to fuzzes than Apache is. Okay, so just doing the brute forcing, quite easy, quite slow. Like, you got to do the authentication and go back and forth. It's a three-way process. It's quite slow, but it can be easily parallelized. And if you do get the administrator password out of this, and they have authentication enabled, maybe you can do a put. There's a lot of things you can do with an actual username password. So this will brute force just via NTLM without basic auth enabled. So sometimes when they have everything else, you can still get a password out of this, although it's kind of slow, so you're going to get lucky. What you're usually going to want to do is take the dictionary file I've got, put a bunch of things in it that resemble the name of the company or whatever that you're fuzzing, and maybe you'll get lucky. So Webman in the middle, there's a couple issues doing sort of web application assessments, especially on web applications that have a custom client that won't use a proxy, which is going to render something like Web Inspect or AppScan completely useless, right? They're not going to go through your proxy. Webman in the middle is a modified version of the Doug Song utility that does host rewriting, can do SSL cleanly, does a lot of nice stuff, and will actually then save off all the requests that you do. And one of the things I think that AppScan and all the other programs like that don't do cleanly that Web Proxy and Webman in the middle do handle is connection keep alive. If you're trying to authenticate with NTLM, you need connection keep alive, right? So I mean, one of the tests you should do when looking at what you should use to do your web application assessments is, can I log into Hotmail with this? If you can't log into Hotmail with it, you're not going to be able to effectively assess anything else, right? I mean, they're very basic applications you should try. So, I mean, that was the test I used when I developed both of these. It's like you can log into Hotmail over this, you can log into Hotmail over Web Proxy. And I think that's one of the major differences. So make web fuzz we've already talked about. And the web fuzz, I'm just going to briefly go over, in case there's anyone in the room who doesn't understand what I mean by fuzzing or web fuzzing. You have a standard request that looks like that and just has a username or password. Spike will parse it properly, and if you've got post variables, it will know what sort of things you have in the post, and it will also handle the get variables, and it will save your cookie for you and all that other stuff. And then obviously that gets replaced with a series of things. This would be the first one, then you have the next one, it would be longer or whatever. And hopefully you're scanning, you save off the output and you're looking for errors, which is quite a simple method of detecting most errors. Or you're attached to the process on the other end looking for exceptions. And most Windows programs handle their exceptions. A lot of the major threaded web servers will handle their exceptions. So if the stack is completely horked, it's going to handle it somehow. And this is a good way to find out how. Closed source web server fuzzer, it doesn't find anything. It didn't find anything on Apache. It doesn't find stuff on Roxen. It does find stuff on IIS, hence the name. And so I wanted to briefly go over kind of how you audit. Why did I care about making this so flexible? You can do mass scanning with ODBC web fuzz if you have a particular need to look at 1,000 pages over and over again for ODBC errors. And it's also a good example for just a quick script that does a large number of web pages looking for a particular bug. And the main other reason would be this is a very exponential problem. If you're looking for one bug, like an overflow that occurs in the username, it's quite easy. If you have to have a particular thing in the password field at the same time so that it generates an error message that causes a format string bug, then it's going to be a lot harder to find. And so, invariably you're going to want to narrow in on certain things. And that's kind of the features that I threw in all the sort of sample tools. So 20K is just the price in the previous slide of all the commercial tools. This is all free. So every part of Spike is open, will be open. You will not have any problems with that. The only thing that is not open are certain Spike scripts and sort of other utilities that I've written around Spike that I sell. So we got to eat. Spike can be extended with anything, and I will happily accept any patches you have, especially regarding making it actually portable. So this is kind of where the automated tools will all fail, and that includes Spike Proxy. They're all going to fail when you have to authenticate to the first page, use something from the first page to throw into the second page, and then fuzz a third page after that. Spike will let you do this, but you do have to have some C knowledge. And I've done this in the past when you need to authenticate, to get into a trading application of some kind. And so if you're looking for that kind of functionality, Spike will give that to you because of its kind of open nature. And another project that's also in Spike is the Spike console. In the long run, I'm going to make it do help you do analysis. I never believe in tools that will do things completely automatically. I'm much more believer in tools that are driven by you like a tank is driven by you. In this case, I'm writing with WX Python. It's semi-portable. The idea is you take an ethereal dump, or you capture from the net, you run it through the Spike console, and you start modifying it, and it will create a little Spike script for you. And as you go through it, you can then quickly send the Spike script a number of times until the protocol works or dies, whichever you're actually looking for. And it will allow you, it'll kind of have sort of graphical macros in it to enable you to quickly disassemble binary protocols. So that's what the Spike console is. It's kind of the GUI around Spike to make Spike a little bit smarter. That's where the brains are going to be, other than in your head, which is where they should be. So there's wizards and all sorts of other stuff. It's beta. It's under heavy development, but I think some of you will find it useful. The most useful part of it right now is the actual just HTTP wizard, which will take any given HTTP request, get, post, or whatever, and make it a Spike script for you. So the future of Spike is Spike console improvements. It's going to support more protocols. It's going to find more bugs. Basically, Spike does whatever I need to do to find more bugs. And it's found a lot of bugs. And some of those bugs you've heard about. And two of them you heard about today. But there's going to be additional things in Spike that find better bugs. So that's kind of the conclusion. You can download it for free at the URL I read out. Does anyone need that read out again? OK. And there's also all sorts of other sort of fun things on that page to look at. And I hope you guys enjoy it. But so that's that. And I'll take questions now if anyone has any. Surely there's got to be one question out there. Does Spike fudge integer values? Not yet, but it would be very easy. It does fuzz string integer values. So if you like throw it into a length field that's a text string, it'll replace it with common things that would cause it to be bad. But it doesn't actually do integer ranges or anything like that yet. So no. But easy patch for the audience. Anybody else? Can you use it against a library? Like, can you basically inject Spike data into another program at kind of a lower level? And the answer is no, not yet. It also doesn't do files, but I mean, files are just I/O, and they're quite easy. So maybe a debugger sort of thing would be useful for that, and I haven't done that yet. Sorry. Okay. Other protocols in the roadmap that I want to fuzz are other database protocols. Basically, it's like whatever my clients come to me and have, right? So like if they've got, you know, a bunch of Java Corba stuff talking back and forth, are they running Fix, which is a financial protocol? Are they running, you know, their own protocol that they invented? These are the protocols that I write up, and the protocols that you write up will hopefully be whatever your customers happen to have running on. I tried to make it quick and easy to write up so that you could be flexible with that sort of stuff. And try to also give a bunch of demos that had similar to what most people would see. So that's that. Someone in the front have a question?
Earlier you were saying about a script will take a request and generate a spike script.
Yeah. I do have a script that will. Yeah, actually, once you've generated that quick Spike script, you just run generic web server fuzz, and it will take as input that Spike script and then do the loop and all that other stuff for you. So then you'll hopefully find an overflow. Right. Can Right now it's kind of a very per request thing. I mean, it depends. If you're looking for something that's very, very, very web centric, it almost makes more sense to plug it into Spike Proxy. Like Spike Proxy and Spike API kind of have a similar name, but you know, they're not as connected as they would have to be to do some of those advanced sort of things. So, yeah, not there yet. Many things are there, many things are not there. So, the code is, I hope, well commented enough that you guys will be able to jump into it, but there's not a whole lot of other documentation around it, other than this talk, which you saw. So it's good. Any questions over here? Okay, I think that's it. If you want to come and check me over here, it's outside.